This meeting is being recorded.
Okay, I'm just going to hand over to James. James is from Viridor, and he's going to speak to you about the power of steam.
Yes, thank you, Vanessa. Good morning, everyone. My name is James Betts, and like Vanessa said, I'm here to talk to you about the power of steam. So currently, I'm a rotating equipment engineer for Viridor. Viridor own and operate 11 energy from waste power stations in the UK. What Viridor do, they collect a lot of the UK's black bag residential waste from homes, from schools, from hospitals and places like that. That waste is sent to their energy from waste power stations where it is burnt to create steam. That steam is then used in the processes to create power. And that's what I'm here to talk to you about today. So I help look after their rotating equipment. That includes pumps, large fans, and their steam turbine sets. I am a steam turbine expert, and that's the reason why I'm currently working with Viridor, helping them today. So I'm sure all of you have seen, and you probably understand the basics of these. These are wind turbines, and they use the wind to create power. You've probably also seen these, obviously an aeroplane, but what I'm interested in here are the gas turbines on the engines. They burn gas to create thrust to get the plane into the air, but also to create the electrical power, which is used on the plane itself. There are also large gas turbines that are used in power stations across the world. You can see one there. You can see the people standing next to it. It's a very large item. And again, that uses the same principle as the aeroplane engines. It burns gas to create power, electrical power in the power stations themselves. But what I'd like to tell you is another turbine called a steam turbine, which generates over 70% of the world's electricity. And for comparison, wind only generates 6. So as you can imagine, there are a lot of steam turbines all over the world, creating power for people all over different countries and on islands. In every corner of the world, there's steam turbines. And there's estimated to be around sort of 300,000 steam turbines in the world, but a lot of people don't know about them. And that's the reason why I've created this presentation for you today. It's been in common use for 120 years. This photo here is called the turbinia. And in 1984, an engineer called Charles Parsons, who was set up a manufacturing business to create steam turbines. No one was purchasing them. No one was interested in them. So what he did, he retrofitted a steam turbine onto a boat, and he called it the turbinia. And he put the steam turbine in, and he went to a naval parade. And what he did, he wasn't invited to that parade, but what he did, he put his boat and went as fast as he could and cut through all of the other boats to show how fast it was, how maneuverable it was, how interesting it was. And from that point on, everyone was very interested in this boat because it was going far faster than all the other ships in the parade, and that sort of spawned interest in the steam turbine itself. At its biggest, the longest steam turbine is actually longer than the biggest airplane in the world, which is the A380 there. This isn't to scale, but this the turbine itself is well over 200 meters long. So it's absolutely huge. The biggest steam turbine in the world is actually being installed at Hinkley Point down in the south coast of the UK. It's not yet installed, but it's being manufactured and installed as we speak, and that's for a nuclear power station at Hinkley C. It's the biggest at the minute is 1,700 megawatts, but the one at Hinkley Point C will be 1,770 megawatts. That is enough power for 5 million UK homes. So it's absolutely huge. It creates a lot of power, and it's extremely efficient. And at the smallest, you can get small steam turbines that I could hold in my hand and pass to you, and it's a few kilograms in weight. but they are used in all different types of processes. So you use a small one for small amounts of steam, and obviously a very large one for when you have lots and lots of steam that you need to use. They're used in power plants. That's a Ratcliffe. That's the Ratcliffe-on-Soar power plant up in Nottingham. That's a coal power station. Industrial processes. This is a steel factory in the south of Wales, Port Talbot. And they also use in oil refineries. And this is a photo where there's actually a steam turbine just located just behind that process building there. They're also used in large ships and even submarines. And a lot of people don't know this. This is a nuclear submarine, and it uses nuclear power to create steam. And that steam is used by a main, they call it the main turbine, which is used for powering the propeller. But it's also used to create, they use steam to create electricity for the submarine. And electricity on a submarine is extremely important because you need to create oxygen for breathing. You need to have power for the computers, for the missiles, controls, everything like that. You need a lot of power. So steam turbines use steam to drive the unit, just like wind is used to drive a wind turbine. And the way that is, this is called the Rankine cycle here. And what it does, fuel is used to create heat. The heat, obviously a lot amount of heat can create steam in a boiler, just like a kettle. So if you can imagine a kettle, obviously you use electricity or you use gas if you've got an old school kettle. And as you heat the water, it creates steam. The heat input into the water creates steam, and that increases the energy in the steam itself. It's very difficult for, I'm sure, I'm not too sure the age range of the people who are looking at this, but it's very difficult to determine what actually is 300 bar. 300 bar is 300 times the atmospheric pressure that we are sort of sitting in today. That's 3,000 meters down below water. If you can imagine that, it's very difficult to imagine, even myself as an engineer, it's very difficult to imagine actually what 300 bar is. But one of the amazing things is the temperatures of the steam can actually reach 620 degrees. So this is hugely pressured, hugely high temperature, and there's a huge amount of energy in that steam. And that's what we want to do. We want to increase the energy of the steam so that we can use that elsewhere to create electrical energy. So this is a coal boiler. Coal is burnt. Obviously, burning coal creates heat, and that heat is transferred through the pipes within the boiler into steam. And that's a basic overview of a coal boiler. There are other boilers as well that are very similar to that. So, for example, biomass, if you're going to burn wood, if you're going to burn waste products. So for Viridor, we burn black bag waste, and that is as you burn the waste, you have plastic, you have cardboard, you have food, you have lots of things that people throw away. That is burnt. That energy is released. As you burn it, it releases the energy, and that energy is transferred into steam in the boiler. Also, there are a lot of power stations out there that burn chicken litter. They also burn carcasses, so dead chickens. During the mad cow crisis a number of years ago, to get rid of the bodies of the cows because it was hugely poisoned, they actually burnt the cows as well in these boilers as well. So you can basically burn anything you want because that has energy in it, can be used in these boilers. For gas turbines, so there are a lot of power stations called combined cycle gas turbines, and what they do is they utilize the waste heat of the gas turbine. They use that in a boiler, and that heat creates steam, and that steam is then fed to the steam turbine, and I'll show you that in a moment. Also, on ships, they have big diesel engines that burn diesel. And the waste heat, so for example, if you think of a car, there's a lot of heat that is exiting that vehicle from the exhaust to to capture that energy, because in this world we want to use as much energy as possible. We want to be as efficient as possible. So to capture that energy, we have a waste heat recovery boiler. So the heat from the diesel engine comes through here, passes through all these tubes, and these tubes are full of water and steam, and that allows you to capture that energy. The heat from the water, the heat from the diesel engine will heat up the water, create steam, and then that's driven through a steam turbine again. And nuclear power stations. So nuclear power stations use uranium rods. So they have uranium rods and they have carbon rods in between the uranium. And what happens is when you remove the carbon rods, the uranium atoms hit each other and create heat. And as they hit each other, they create a nuclear reaction. So it's nuclear fusion reaction, where it creates energy, creates heat, and that boils the water and creates steam. And you can see a sort of a basic process here, but it's very, very similar. The basic process, the basic sort of fundamentals is you create heat, you capture that heat within water, and that water creates steam. So just think of it as a very, very big kettle. That steam is obviously, like I say, the temperature and the pressure increases. That increases the energy in the steam. That is then fed into a steam turbine. The steam passes through the steam turbine, and I'll show you photos of those, of the steam turbine. And it passes, as the steam passes through the turbine, the energy from the steam is extracted and converted from potential energy and thermal energy within the steam into mechanical rotational energy. So it's an energy conversion process. You take the energy from the steam, you convert it into mechanical energy. Just like if it's very difficult to visualize, but if you think of obviously the energy in the wind is captured by a wind turbine. It's the same principle, but rather than using wind, we're using steam. Sorry. So here's a steam turbine here. You've got a number of different rows. You've got a number of different blades. And what happens is, as the steam passes through the blades, so it goes through this first row, then the second row, third row, fourth row, it passes along that towards the exhaust. And as the steam passes from the inlet of the turbine, where the temperature and the pressure is high, that as you extract energy, the temperature and the pressure within the steam reduces and reduces and reduces and reduces, because you want to take as much energy from that steam as possible. So when you do that, the pressure in the steam reduces, the temperature in the steam reduces, and then you get to the exhaust here. Again, another unit. This is one. These are both Viridor units. This is a Viridor unit up at Glasgow. This one here is a Viridor unit at Runcorn, where we operate the biggest energy from waste power station in the UK. And this one here is from this one's from Peterborough, just down the road from myself here. This one is again another unit, and as you can see, this is actually from Oxford. As you can see, it's quite an interesting unit. It's quite good to look at. It's a lot of engineering, a lot of engineering and design work has gone into this. This is extremely efficient unit, and yeah, very, very expensive. These are millions of pounds worth of equipment here. This is a common size steam turbine. So like I say, you can get a very small unit which you can hold in your hands. You get a very, very big unit, which is sort of the world's biggest. But this is the most common. This is a probably, I don't know, if you talk about in megawatts, that's how we normally rate the units based on the power. This is probably a 20-25 megawatt unit. The world's biggest, obviously, like I say, is 1,770. And the most common is probably around the 10 to 30 megawatt units. So most of them are quite small. This is actually one of the rotors from the world's biggest. And as you can see, the size of it is absolutely huge. You can see the people at the bottom. That rotor is probably as big as a normal size 3-bedroom semi-detached house that many of you probably live in, that I live in. That blade is over 1 meter long. It's absolutely huge. And this is only one of them. This is only one rotor. There are actually 3 more connected to this. So if I show you the location here, this is one rotor in the middle. There's another rotor on the right of it, another rotor on the left of it, and then there's another rotor at the end here. And this is shown here in this picture here. You can see it's absolutely huge. And this is a nuclear power station in Finland, Olkiluoto. This is the world's biggest at the moment, but like I say, the next world's biggest is being built in Hinkley Point C. And there we go. Thank you for your time, and please ask me any questions you want.
There was one question, James, that popped up in chat. Your very first slide with the turbina boat, it had the date 1984.
Oh, sorry. Yeah, you're right. Yeah, 1884. Sorry, apologies for that. That's a typo. Yeah, you're right. Yeah, I'll change that. Thank you for that.
That's okay. So have we got any other questions at all from the students? Okay, so while we're waiting, what made you go into this field of work, James? What were you interested in when you were at school, and what led you onto this path?
Yeah, so in school, I was very much interested in engineering. My grandfather was an engineer, and he used to take me into the shed, and he used to fix mechanical clocks, and that got me very interested in engineering. So when I was at school, I was always taking things apart and having a look at things. I very much enjoyed the engineering and design, sort of the design work that we did there. And then afterwards, I actually wanted to go into wind turbine engineering, but there was so much interest and so much that I didn't actually get accepted into that, and I was transferred across to the steam turbine unit for Siemens. Actually, it was up in Newcastle, and that started it off from day one. And I'm very, very lucky to be in this industry, where the steam turbine industry specifically, because there is so much demand for it. The steam turbines will be the future, because nuclear power stations need steam turbines, and so I'm always going to be in a job. It's extremely interesting. I've traveled all over the world looking after steam turbines, from America, Brazil, Mauritius, like all these places, Pakistan, everywhere. I've been all over the world, so it's an extremely interesting industry, extremely busy, extremely demanding, and also very fulfilling. So I've ever since I left university, I've been in the steam turbine industry.
So one question that's popped up in chat is, what did you study to get into it? So what subjects did you take?
So at school, I did maths so GCSE is obviously all the standard, but when I went to A levels, I did maths and physics, and that gave me a lot of information, a lot of fundamentals, grounding, and it's, as an engineer, I do a lot of maths, I do a lot of physics, and yes, those are the two subjects I really. That if you want to be an engineer, it's good to concentrate on those two.
There aren't any other questions in chat, so I think you had a very in-depth presentation. I think you've covered everything, which is good. That was great. Thank you ever so much for your time, James, and thank you, Sir John Lehman High, for joining us this morning. Thank you.
Thank you very much.